Hi there, welcome to Ancient Cosmos Sleep. Tonight we drift into a universe so vast that almost everything you can see is actually nothing. You float between scattered islands of light, surrounded by distances so enormous that numbers begin to lose their meaning. Every glowing galaxy promises company, every bright star seems close enough to reach, yet the moment you begin the journey, you discover that space is mostly an endless ocean of silence. It is beautiful in the way an empty cathedral is beautiful, grand, peaceful, and just a tiny bit unsettling. And here's your cheerful bedtime reality check. If you somehow stepped outside without the protection of physics, you probably won't survive this. Thankfully, tonight you're traveling only with your imagination, which is considerably easier to ensure. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here, and while you're settling in, let me know where you're listening from and what your local time is. It's always fascinating to imagine people around the world sharing the same quiet journey beneath entirely different sky. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You open your eyes, and there is almost nothing. Not darkness exactly. Darkness suggests something waiting to be illuminated. This is different. Around you stretches a landscape so empty that even the concept of around begins to feel generous. Somewhere, impossibly far away, a handful of stars sparkle like grains of salt tossed across an ocean larger than imagination itself. Your first instinct is surprisingly human. You wonder where everybody is, not because you're expecting traffic in space. Even the busiest part of our cosmic neighborhood would make the quietest country road look like downtown rush hour. Still, your brain evolved on a planet where empty places rarely stay empty for long. Birds eventually sing, wind eventually blows, someone eventually forgets where they parked. Out here, nothing eventually happens. That realization arrives slowly, like cold air slipping beneath a blanket. The night sky, viewed from Earth, tricks you. It appears crowded, sprinkled with countless stars that seem almost shoulder to shoulder. Ancient civilizations naturally imagined celestial domes because the heavens looked comfortably close together. One mainstream historical fact is that the Greek astronomer Hipparchus catalogued hundreds of visible stars more than 2,000 years ago, helping create one of humanity's earliest systematic maps of the heavens. Standing beneath the same sky, he could hardly have guessed the staggering emptiness separating those points of light. You probably would have guessed the same. After all, perspective is an expert illusionist. Imagine shrinking the sun until it's the size of a tennis ball. Earth immediately becomes smaller than a peppercorn orbiting about 25 meters away. That already feels spacious. Now imagine the next nearest star. Keeping everything to scale, it isn't across the street. It isn't in the next city. It would be thousands of kilometers away. Suddenly, the neighborhood around our sun resembles a single mailbox standing alone somewhere in the Sahara Desert. And that's considered crowded. Space has an extraordinary talent for making even loneliness feel lonely. Here's the first gentle joke of the evening. If real estate agents handled interstellar property, every listing would proudly announce, "Excellent privacy. Nearest neighbor only 4 light years away." Technically accurate, probably difficult to commute. As your imaginary journey continues, Earth quietly disappears behind you. The moon fades first, then the planets, then even the sun becomes another anonymous star among billions. You might expect this moment to feel frightening. Instead, it feels strangely peaceful. Without cities, traffic, notifications, or someone asking whether you've tried turning it off and on again, the silence becomes almost comforting. Almost. Because eventually your thoughts catch up. If the universe is so unimaginably large, why does so little occupy it? Modern astronomy estimates that galaxies themselves occupy only a tiny fraction of the observable universe. Between them lie incomprehensible expanses where there are no stars, no planets, sometimes not even a single wandering atom for enormous distances. You begin realizing something curious. The stars are not the story. The emptiness is, throughout history, humans tended to imagine creation as filling space. Ancient myths often described gods separating chaos into ordered lands, seas, and skies. Yet modern cosmology reveals almost the opposite. The universe is remarkably efficient at producing nothing, not absolute nothing, of course. We'll eventually discover that true emptiness is surprisingly complicated. But for now, your journey is simple. You drift, hew after imaginary hour, nothing approaches, nothing passes, even light, the fastest traveler in existence, struggles against these distances. A beam leaving one galaxy may wander for millions of years before finding another destination. Think about that. Dinosaurs appeared and vanished during periods shorter than some photons and spend traveling between neighboring galaxies. That's enough to make anyone feel delightfully unimportant or wonderfully free. Perspective works both ways. Here's another small smile before we continue. Somewhere in the cosmos, there could theoretically be the slowest neighborhood watch ever organized. Suspicious object approaching. Estimated arrival, 18 million years. Nobody's losing sleep over that meeting schedule. Yet scientists continue staring into this immense quiet. Powerful telescopes grow larger every decade. Radio dishes listen patiently. Spacecraft leave home carrying messages engraved onto golden records. Human curiosity refuses to accept silence as the final answer. Historians still argue whether ancient philosophers truly believed empty space could exist at all, or whether they imagined every corner of reality filled with some invisible substance. The debate stretched from Aristotle through centuries of thinkers, showing just how difficult the concept of a vacuum has always been for the human mind. And perhaps that difficulty never really disappeared. Because when you picture space, your imagination still wants to add something. Clouds, dust, ships, anything. The real universe politely declines. It offers distance instead, an almost absurd abundance of it. There is also a wonderfully quirky historical tidbit. During the 17th century, some Europeans believed carrying a small piece of meteorite iron could protect travelers from misfortune because stones from the heavens seemed touched by divine mystery. Whether or not anyone felt safer is impossible to know, but it's charming to imagine someone trusting a cosmic rock more than their map. You continue drifting. The stars no longer resemble destinations. Instead, they become punctuation marks scattered through an impossibly long sentence. Between every glowing word lies page after page of blank paper. And perhaps that blankness isn't an accident. Perhaps the universe is not mostly empty because something failed to happen. Perhaps emptiness is the design itself. That thought settles gently beside you, not as fear, not yet, just curiosity. Because if almost everything is nothing, then maybe the nothing deserves as much attention as everything else. The silence around you no longer feels like an absence. It feels like a clue. And as your eyes slowly adjust to the overwhelming scale, you notice faint islands of light ahead, entire galaxies floating alone across the darkness, each believing, in its own quiet way, that it has neighbors. The journey toward those lonely islands has only just begun. Those distant islands of light grow almost imperceptibly larger. Although larger is a generous description when every step of your journey spans millions of years. If patience were a fuel source, you would now possess enough energy to outlast civilizations. The funny thing is, nothing about the view seems to change. That is one of the universe's favorite tricks. You can travel incredible distances and still feel as though you've barely moved. Imagine walking across the world's largest beach, except every grain of sand is replaced by entire star systems, and the nearest seashell is several billion kilometers away. After a while, your brain simply shrugs and says, "Everything looks equally far." It isn't wrong. You continue drifting toward what first appeared to be a single glowing patch. As it slowly sharpens, the light separates into hundreds of billions of individual stars gathered together by gravity. This is not just a collection of suns, it is an island, an entire galaxy. From Earth, galaxies often look like graceful spirals or soft elliptical smudges. They seem almost close enough to reach across the night sky. But appearances remain wonderfully deceptive. If our Milky Way were reduced to the size of a dinner plate, the nearest large neighboring galaxy would still sit several meters away. That doesn't sound alarming until you remember each dinner plate contains hundreds of billions of stars. It's as though someone placed two bustling cities on opposite sides of a continent and declared them neighbors. Technically correct, socially inconvenient. You might imagine galaxies floating through space, like crowded cruise ships crossing a peaceful ocean. They're actually more like solitary lighthouses separated by entire oceans that never end. Here's tonight's first gentle laugh. Cosmic neighborhood block parties are remarkably easy to organize. Attendance, however, usually requires traveling for a few billion years. The RSVP deadline is understandably flexible. The galaxy before you hums with quiet activity. Stars are born, stars age, planets circle invisible paths. Somewhere, perhaps, life looks up from an alien shoreline and wonders whether anyone else exists. They would see exactly what you see: distance, almost insulting amounts of distance. The Milky Way itself stretches roughly 100,000 light-years across. That sounds enormous because it is. A beam of light, the fastest thing the universe allows, would need 100,000 years simply to cross from one side to the other. Think about what humanity was doing 100,000 years ago. Our ancestors were living long before cities, agriculture, writing, or even the oldest myths ever recorded. While generations rose and disappeared on Earth, a single photon could still be making its leisurely trip across our own galaxy. Suddenly, your calendar feels adorably optimistic. One mainstream historical fact fits beautifully here. In the 18th century, the astronomer William Herschel began systematically mapping the stars of the Milky Way, attempting to understand our place within it. Using telescopes far simpler than modern instruments, he realized the heavens possessed structure rather than random arrangement. His work transformed the night sky from decoration into geography. Yet even Herschel couldn't fully appreciate just how isolated galaxies truly were. That revelation waited for another era. You continue onward. Eventually, the galaxy drifts behind you. Nothing dramatic happens. No invisible wall marks its edge. The stars simply become fewer, then fewer still, then astonishingly scarce. The emptiness returns with quiet confidence. It reminds you of walking away from a campfire into a moonless forest. The warmth fades so gradually that you hardly notice until you suddenly realize you're alone with the cold. Except here, there isn't even cold in the ordinary sense. Temperature becomes a strange concept where almost nothing exists. You float through an intergalactic wilderness. The nearest star may now be hundreds of thousands of light years away. There are no glowing planets passing beneath your feet, no colorful nebulae wrapping around your path. Just scattered hydrogen atoms so thinly distributed that, if gathered into Earth's atmosphere, they would seem almost non-existent. Space has mastered minimalism. Interior designers would call it clean. Physicists call it reality. Somewhere behind you, galaxies continue spinning gracefully, each containing stories beyond counting. Ahead of you, another island, and another, each one disconnected from the others by expanses almost impossible to comprehend emotionally. This is where your intuition begins protesting. Surely the universe wouldn't waste so much room. Human beings dislike unused space. We build houses and immediately fill them with furniture, then shelves, then decorative baskets whose purpose remains mysterious. Apparently, the universe never received that memo. Instead, it left enormous blank pages between every chapter. Historians still argue whether some early cosmological models underestimated the scale separating galaxies because the distances seemed almost absurd, even to professional astronomers. The leap from imagining one stellar system to imagining billions of isolated galaxies required humanity to completely rethink its place in existence. That rethink continues today, because knowing something mathematically differs greatly from feeling it, you are beginning to feel it. Here's another small joke to keep things comfortably sleepy. Somewhere, an alien teenager probably complains that there's absolutely nothing to do around here. Statistically speaking, they might be the most correct teenager in the observable universe. You drift through millions of light years that contain almost no visible landmarks. The silence changes your perception. Back on Earth, silence usually means waiting for something, a bird, a passing car. The refrigerator deciding it's suddenly very important. Here, silence simply exists. It asks nothing of you. It expects nothing. It has existed longer than mountains, oceans, or every language ever spoken. There is something unexpectedly comforting about that. Then an odd thought appears. Perhaps galaxies themselves are not meant to touch. Gravity certainly tries. It binds stars together. It gathers gas into glowing nurseries. It shapes elegant spirals visible across billions of light years, yet beyond each galaxy lies expansion, patiently encouraging separation. Like dancers who can hold hands only briefly before the music gently pulls them apart, a wonderfully quirky historical tidbit comes to mind. During the 19th century, a few enthusiastic observers believed they could see enormous canals on Mars through their telescopes. Those famous canals inspired dreams of advanced civilizations engineering entire planets. The lines turned out to be optical illusions, but they remind us how eagerly the human mind fills empty places with imagined company. You smile at the thought. Perhaps your own imagination has been doing something similar all evening. The farther you travel, the more obvious it becomes that emptiness is not merely the background. It is the canvas. Galaxies are the brushstrokes. Without the vast darkness surrounding them, their beauty would almost disappear. A diamond shines because of the velvet beneath it. A lighthouse matters because of the sea around it. A single warm window catches your eye because the night is otherwise dark. The universe understands contrast remarkably well. And yet, a quiet question refuses to leave. Why should such an immense universe produce so many isolated islands instead of one endless continent of stars? Was it inevitable? Was it chance? Or does this loneliness serve a purpose written into the laws of physics themselves? You continue gliding onward, carrying those questions with you. Far ahead, the darkness begins changing almost too subtly to notice. It isn't becoming brighter, it's becoming stranger. The scattered galaxies seem to curve around enormous regions where almost nothing exists at all. As though the universe has carved gigantic invisible valleys between its luminous islands. You are approaching a place where emptiness becomes even emptier, and the great cosmic desert is waiting in complete, patient silence. The darkness ahead slowly changes character. At first, you suspect it is another illusion of distance. Space has been playing those little tricks on your perception ever since you left Earth behind. But this feels different. The galaxies that once appeared scattered almost randomly now seem to gather along enormous invisible threads, leaving astonishingly vast regions where almost nothing exists. You drift toward one of those regions. Calling it empty somehow feels inadequate. It is less like sailing across an ocean and more like discovering an entire continent made of silence. Astronomers call these immense regions cosmic voids. The name sounds wonderfully dramatic, yet it barely captures their scale. A cosmic void is not simply an area with fewer stars. It is an enormous volume of space containing dramatically fewer galaxies than average, sometimes stretching hundreds of millions of light-years across. Imagine every major city on Earth connected by highways. Now erase entire countries until only a few isolated clusters remain, then increase the scale until those countries are larger than everything your species has ever known. You begin to understand why the word void survived scientific scrutiny. There simply wasn't a better one. As you continue drifting inward, the last nearby galaxy slips behind you. Ahead lies a darkness so complete that your mind instinctively searches for landmarks. There are none. Your imagination wants to invent them anyway. Perhaps a hidden star, perhaps a distant nebula, perhaps a friendly little coffee shop floating between galaxies. Even a machine serving slightly disappointing espresso would be comforting right now. Unfortunately, intergalactic customer service remains rather limited. That's your first gentle joke for this stretch of the journey. The silence grows thicker. Not because sound exists here, but because your expectations slowly disappear. On Earth, emptiness is usually temporary. An empty room eventually fills. An abandoned road eventually welcomes another traveler. Even deserts host life if you know where to look. The cosmic desert is under no such obligation. It has remained largely unchanged for billions of years. One mainstream historical fact helps explain how astonishing this discovery truly was. In the late 20th century, astronomers conducting large-scale galaxy surveys began mapping the universe in unprecedented detail. Instead of finding galaxies evenly distributed through space, they uncovered an immense cosmic web, long filaments packed with galaxies surrounding gigantic empty regions. It was rather like expecting scattered raindrops and instead discovering a colossal sponge. The universe, it seemed, preferred architecture. You picture those filaments now, enormous glowing strands stretching across unimaginable distances. At every intersection, galaxies gather into crowded clusters. Between them, nothing or almost nothing. That distinction matters because even the emptiest void isn't perfectly empty. Here and there drift lonely atoms, faint wisps of hydrogen, invisible particles crossing paths only after journeys lasting longer than Earth's entire biological history. If 1 cubic centimeter of ordinary air contains around 25 quintillion molecules, the same volume inside one of these vast voids may contain only a tiny fraction of a single atom on average. You pause on that comparison. Actually, pause isn't quite right. You never stop moving. Nothing does. But your thoughts linger. You suddenly realize that the emptiest places in the observable universe are emptier than the finest laboratory vacuums humans have ever created. Nature quietly outperforms engineering, Agon. Historians still argue whether humanity's growing ability to visualize the large-scale structure of the universe fundamentally changed our philosophical understanding of existence, or whether it merely confirmed ideas that had already begun taking shape centuries earlier. Either way, standing, or rather floating, inside one of these voids feels profoundly different from reading about one. Knowledge becomes experience, numbers become loneliness, and loneliness becomes strangely beautiful. Here's another small smile before we drift farther. If someone accidentally dropped their car keys in a cosmic void, the search party might reasonably conclude that walking home would be faster, not that there is a home nearby, or walking. Small logistical details. You continue deeper. The galaxies now resemble distant campfires left behind on every horizon. Except there are no forests, no mountains, no horizon at all, just depth. Infinite seeming depth. Your eyes, if they could truly adjust to this environment, would eventually notice something remarkable. Darkness itself is not perfectly uniform. Far beyond the visible galaxies lies the faint afterglow of the early universe, still whispering across space. You won't reach that story just yet. For now, you remain surrounded by an astonishing absence. It raises an uncomfortable question. Why should gravity, one of the most persistent forces in nature, allow such gigantic empty regions to exist? Wouldn't matter naturally spread itself more evenly? The answer turns out to be delightfully counterintuitive. Tiny differences in density, shortly after the Big Bang, slowly amplified over billions of years. Regions with slightly more matter pulled in even more. Regions with slightly less gradually surrendered what little they had. The rich became richer, the poor became poorer. Even the universe apparently understands compound interest. There's your third gentle joke. Some lessons truly are universal. As countless ages passed, gravity sculpted the magnificent cosmic web surrounding you. Matter flowed outward from the emptiest regions like water draining from shallow valleys. The voids became emptier still, the galaxy clusters became denser, not because someone planned the design, because simple physical laws repeated patiently over immense stretches of time. That patience is difficult for human minds to appreciate. You think in years, perhaps decades. Civilizations think in centuries. Stars think in billions of years. The universe barely notices. A wonderfully quirky historical tidbit drifts into your thoughts. During the 18th century, some natural philosophers speculated that empty space might actually contain an invisible substance called the luminiferous ether, a mysterious medium through which light supposedly traveled, much as sound travels through air. It was an elegant idea, comforting. Even the universe, however, politely declined the offer. Experiments eventually showed that light needed no such invisible ocean. Space could be astonishingly empty after all. You continue drifting through the great cosmic desert. Time loses its familiar rhythm. Without sunrise or sunset, clocks become almost philosophical objects. What exactly measures a day when no planet spins beneath your feet? You stop counting. The void doesn't mind. It has never cared for calendars. Oddly enough, neither do you anymore. Instead, your attention settles on something unexpected. The emptiness itself has texture. Not visible texture, but conceptual texture. It is shaped, defined. Its boundaries emerge only because galaxies outline them, like distant shorelines tracing invisible seas. You are no longer looking at isolated objects. You are looking at absence given form. That realization carries surprising emotional weight. Perhaps emptiness is not merely what remains after everything else has been placed. Perhaps emptiness is one of the universe's fundamental building materials. The stars provide the punctuation, the voids provide the meaning. And somewhere beyond this immense desert, space itself is quietly stretching, pulling every island of light a little farther apart with each passing moment. You cannot feel that expansion. Nothing tugs at your shoulders. No wind whispers through the darkness. Yet it is happening all the same, portedly, relentlessly, as though the universe has already decided that even these lonely galaxies are still far too close together. That invisible stretching is about to become the most unsettling part of your journey. The emptiness around you feels complete. Surely, you think, space cannot become any more spacious than this. The universe responds with its usual quiet confidence. Oh, it absolutely can. You continue drifting through the immense cosmic void, watching distant galaxies sparkle like tiny lanterns scattered across an endless sea. Nothing appears to move. There is no rushing wind, no sensation of speed, no visible current carrying you onward. And yet everything is moving, not simply through space. With space, that small difference turns out to be one of the strangest ideas humanity has ever discovered. When you picture the universe expanding, your imagination probably produces something rather sensible. Perhaps you imagine galaxies exploding outward from a central point like fireworks. Or maybe you picture a giant cosmic balloon inflating into an even larger room. Both images are useful. Neither is quite right. There is no central explosion you could point toward. No privileged location where everything began. No cosmic middle marked with a helpful sign reading, "You are here." Instead, space itself stretches everywhere at once. Imagine drawing tiny dots across the surface of a balloon. As the balloon inflates, every dot sees every other dot moving farther away. None of the dots occupies the center of the expanding surface. From each one's perspective, everything else is retreating. The universe behaves in a surprisingly similar way, except instead of a balloon's rubber stretching through ordinary air, the fabric of space itself slowly grows larger. Your brain objects immediately. Fabric? Space? Surely that's just a metaphor. It is mostly. Physicists often borrow familiar words because everyday language struggles to describe realities that have no ordinary equivalent. Fabric is not perfect, but it gently nudges your imagination in the correct direction. The important part is this. Galaxies are not racing through empty space as much as the space between them is gradually increasing. It's like placing raisins inside rising bread dough. As the dough expands, each raisin notices every other raisin drifting farther away, despite remaining embedded in the same loaf. Fortunately for the raisins, they rarely stop to worry about cosmology. One less thing on their minds. There's your first sleepy joke of the evening. You, however, continue worrying on behalf of the raisins. Because this stretching changes everything, one mainstream historical fact marks the beginning of this remarkable realization. In 1929, the astronomer Edwin Hubble published observations showing that distant galaxies generally move away from us, with farther galaxies receding faster than nearby ones. The discovery revolutionized astronomy almost overnight. Suddenly, the universe was no longer static. It was dynamic, alive with motion, expanding. At first, the idea felt almost unbelievable. For centuries, many scientists assumed the universe had always existed in roughly the same form. A changing universe seemed unnecessarily dramatic. The universe politely ignored those preferences. It expanded anyway. You watch the process unfold in impossibly accelerated imagination. Millions of years pass like drifting clouds. Galaxies slowly separate. Clusters become more isolated. The immense void behind you grows even larger. The distances were already difficult to comprehend. Now they refuse to remain constant. It's rather like discovering that every road on Earth quietly becomes a little longer each morning while nobody is looking. Commuters would have questions. Astronomers certainly did. Historians still argue whether Einstein's introduction of the cosmological constant represented his greatest mistake, as he later reportedly suggested, or whether it accidentally anticipated one of the deepest mysteries in modern cosmology. Scientific history enjoys that sort of irony. Sometimes an abandoned idea quietly returns decades later, wearing a much better suit. You continue drifting. At first, expansion feels almost harmless. Galaxies remain magnificent. Stars continue burning peacefully. Planets still orbit their suns. Gravity successfully holds nearby systems together. Your own Milky Way, for example, isn't being torn apart by cosmic expansion. The stars within it remain gravitationally bound, dancing around the galactic center much as they always have. Your solar system certainly isn't expanding. If it were, Earth would have developed some rather awkward scheduling issues. Imagine your calendar notification. Planet has drifted another few million kilometers today. Expect seasonal delays. Probably best to work from home. There's your second gentle laugh. Gravity, it turns out, is stubborn. Within galaxies, gravity easily overpowers the slow expansion of the universe. Within solar systems, it dominates even more completely. Even your coffee cup sitting on a table back on Earth has absolutely no interest in participating in cosmic expansion. The table is winning that argument, comfortingly so. But on truly enormous scales, expansion quietly takes over. The farther apart two galaxies begin, the more stretching accumulates between them. Every million years adds another tiny amount. Tiny plus tiny plus tiny eventually becomes extraordinary. The universe possesses infinite patience. It never hurries, it never grows tired, it simply keeps stretching. As you continue your journey, the consequences begin revealing themselves. Those lonely galactic islands you visited earlier, they are becoming lonelier. The cosmic web itself slowly loosens, filaments lengthen, voids widen. The architecture of the universe subtly changes, not through violence, but through relentless separation. It almost resembles watching old friends move farther away one quiet year at a time. Nobody argues. Nobody slams doors. Life simply carries everyone onto different paths until reunions become impossible. That thought lingers with surprising tenderness. Perhaps because human lives understand distance, emotionally, even when we cannot comprehend it physically, a wonderfully quirky historical tidbit floats into view. In the early 20th century, before the expanding universe became widely accepted, some people imagined spiral nebulae were merely gas clouds inside our own galaxy. Others insisted they were entirely separate island universes. The phrase sounded poetic. It turned out to be astonishingly accurate. Entire universes of stars, separated by oceans of emptiness. You now drift among them yourself, or at least your imagination does. The silence remains almost unchanged, yet something fundamental has shifted. You realize emptiness is not a fixed landscape. It is growing. The gaps between galaxies are not simply large. They are becoming larger. That realization transforms the quiet into something subtly unsettling, because if expansion has continued for billions of years, it will continue tomorrow, and the day after, and long after the last language spoken on Earth has vanished into history. Nothing in the universe asks permission. Sins simply unfolds portently, elegantly, relentlessly. You begin wondering what future astronomers, if any, still exist unimaginably far ahead, will actually see when they look into the night. Will they still recognize neighboring galaxies? Will they know the universe once looked crowded compared with their own sky? Or will expansion eventually hide almost everything beyond their reach? The question hangs before you like a distant star. Beautiful, quiet, and just a little terrifying, because somewhere ahead lies a future where the universe itself begins erasing its own visible history, one disappearing galaxy at a time. The galaxies ahead remain visible. For now, they still decorate the darkness with elegant spirals, glowing ellipses, and faint bluish pinwheels, each one carrying billions of stars and untold histories. They seem permanent, almost reassuring. After all, the night sky has always felt dependable. Humanity has looked upward for thousands of years, finding familiar constellations, familiar planets, familiar rhythms. It is easy to mistake familiarity for permanence. The universe smiles quietly at that assumption. You continue drifting, and time begins to accelerate in your imagination. Millions of years slip by like leaves floating downstream. Entire mountain ranges on Earth rise and erode. Oceans advance and retreat. Species appear, flourish, and disappear without leaving a single witness. Out here, the galaxies barely seem to notice, but they are moving, always moving. The stretching of space that seemed almost harmless before now begins to reveal its long-term consequences. One by one, the distant galaxies become harder to see. Not because their stars have gone out, not because great cosmic disasters have destroyed them, simply because they have moved so far away that their light grows weaker, redder, and increasingly difficult to detect. Imagine standing on a shoreline at sunset. A ship slowly sails toward the horizon. Nothing dramatic happens. It does not explode. It does not sink. It simply becomes smaller, then dimmer. Then one day you realize you can no longer see it at all. The ship still exists. It has merely crossed beyond your reach. That is exactly what the expanding universe will eventually do with entire galaxies. One mainstream historical fact makes this realization even more remarkable. In the late 1990s, two independent teams studying distant exploding stars, type Ia supernovae, made a startling discovery. They found that the universe is not merely expanding, its expansion is accelerating. Instead of slowing under gravity's pull, the expansion appears to be speeding up. Few scientific discoveries have surprised cosmologists more. It was rather like tossing a ball into the air, expecting it to slow down, only to watch it climb faster and faster all by itself. Things occasionally enjoys dramatic plot twists. You float quietly as that thought settles. Acceleration. Not constant expansion, increasing expansion. The distances between the great galactic islands are growing ever more rapidly. For civilizations living billions or even trillions of years from now, the observable universe may look astonishingly different. Imagine being born in such a distant future. You step outside beneath your world's night sky. You see your home galaxy. Perhaps a few nearby companions still gravitationally bound together. Beyond that, nothing. No magnificent tapestry of distant galaxies, no countless spirals scattered across the heavens. No evidence that the wider universe ever existed, just darkness. An immense, silent darkness. Here's your first gentle joke before that thought becomes too heavy. Future astronomers might confidently publish a paper titled Comprehensive Survey of the Entire Universe. Page 1. We checked. This appears to be it. Peer review would certainly be shorter. The idea feels almost unfair. Today you live during a remarkable cosmic moment. The universe is old enough for galaxies to have formed, but young enough that many remain visible across enormous distances. You occupy a brief window in cosmic history when the evidence of the larger universe is still available. That realization carries a quiet sense of gratitude, not because humanity is especially important, but because curiosity arrived at precisely the right time. Historians still argue whether future civilizations, deprived of visible evidence for cosmic expansion, could rediscover the true history of the universe using only local observations, or whether the expanding cosmos will permanently erase crucial clues. It is one of those rare scientific questions whose answer depends not on intelligence, but on timing. The universe itself controls what can be seen. You continue drifting. The darkness ahead grows deeper, not emptier in reality, only emptier in appearance. That distinction matters enormously. Galaxies beyond the expanding cosmic horizon do not cease to exist. Their light simply loses the race against expanding space. Every photon they emit struggles toward you. Meanwhile, the universe quietly stretches the distance it must travel. Imagine trying to walk toward a friend while the moving walkway beneath your feet carries you backward faster than you can walk forward. No matter how determined you are, you never arrive. Light itself faces that challenge across the expanding cosmos. The farther away a galaxy becomes, the more difficult its light finds the journey. Eventually, impossible wins. That sounds almost poetic. Unfortunately for the photons, physics rarely negotiates. A wonderfully quirky historical tidbit slips into your thoughts. In the 17th century, some scholars believed the stars were tiny holes in a crystal sphere through which the light of heaven shone. It seems wonderfully imaginative today, yet it reminds you how naturally humans invent explanations when confronted with mysteries too vast to measure. Modern cosmology has replaced crystal spheres with expanding space-time. Stranger, perhaps. certainly better supported, yet no less awe-inspiring. You imagine standing beside a future child looking up into that nearly empty sky. They ask the same question children have asked for countless generations. What's out there? You hesitate, not because nothing exists, because almost everything has slipped permanently beyond observation. Their universe feels small, your universe feels immense, the physical reality is identical. Only the visible evidence has changed. That is perhaps the most unsettling trick the cosmos ever performs. It hides its own past. Libraries preserve history, tree rings preserve history. Ice cores preserve history. The universe, given enough time, quietly edits its own autobiography, not maliciously, not intentionally, simply through expansion. Here's another gentle smile before we continue. Imagine trying to explain billions of invisible galaxies to someone whose telescope shows only darkness. It would sound suspiciously like insisting there's a dragon living just beyond the next hill. Scientific conferences might become wonderfully awkward. You continue floating through unimaginable ages. Your own galaxy slowly merges with its nearest companions, bound together by gravity, while the rest of the cosmos fades away. Nearby stars still shine. Planets still orbit. Life, if it survives, continues beneath familiar constellations. Yet the greater universe has become inaccessible, invisible, almost mythical. The loneliness you sensed earlier now acquires a deeper meaning. It is not simply that galaxies are far apart. It is that time itself steadily increases their separation until even memory becomes difficult to verify. You realize something quietly profound. The observable universe is not a permanent feature of reality. It is a temporary gift. One day, unimaginably far ahead, countless civilizations may never know that billions upon billions of galaxies once illuminated the heavens. Their skies will whisper only silence. And somewhere beneath that silent sky, someone will still wonder whether the universe has always been so empty. Ahead, however, another witness still survives. A faint glow older than every galaxy you've passed, carrying a message from a time before stars themselves were ever born. Its ancient light has been traveling toward you since the universe was young. And it has a story unlike any other. Long before the first star ever ignites, before the first galaxy slowly gathers itself from drifting clouds of hydrogen, before planets, oceans, mountains, or anyone ever wonders what lies beyond the next horizon, there is light, not the brilliant light of a nearby sun, not the blue glow of a young star cluster, something older, far older. As you continue drifting through the expanding darkness, you begin noticing a glow that doesn't seem to come from any particular direction. It is astonishingly faint, almost beyond imagination, yet it surrounds everything equally. You cannot point toward its source, because its source is, in a very real sense, everywhere. This is one of the oldest messengers still traveling through the universe, the cosmic microwave background. Its name sounds more like an appliance manual than one of the greatest discoveries in science. But don't let that fool you. Hidden behind those rather unremarkable words is a story that reaches almost all the way back to the beginning of cosmic history. Imagine arriving at a campfire hours after everyone has gone home. The flames are gone, the smoke has faded, yet the stones remain warm beneath your hand. The cosmic microwave background is something like that lingering warmth, not the fire itself, its fading memory. You slow your thoughts, letting that image settle gently. Nearly 13.8 billion years ago, the universe was unimaginably hot and dense. It wasn't filled with stars, because stars could not yet exist. Matter and light were tangled together in an energetic fog so intense that photons, the tiny packets of light, could barely travel any distance before colliding with charged particles. The universe was bright, but strangely opaque. It resembled a glowing cloud rather than a clear night sky. Then something extraordinary happened. As expansion continued, the universe cooled, very gradually, very patiently. Eventually, after roughly 380,000 years, temperatures dropped enough for electrons and protons to combine into neutral hydrogen atoms. Suddenly, photons found themselves free. They no longer bounced endlessly from particle to particle. They escaped. And they have been traveling ever since. One mainstream historical fact beautifully illustrates how remarkable this discovery was. In 1965, radio astronomers Arno Penzias and Robert Wilson were investigating persistent background noise in a large horn-shaped antenna. They checked everything they could think of, including pigeon droppings inside the instrument, yet the mysterious signal refused to disappear. Eventually they realized they had accidentally detected the ancient afterglow of the early universe itself. Imagine cleaning bird mess from your equipment and accidentally confirming one of cosmology's greatest predictions. Science occasionally has an excellent sense of humor. There's your first gentle joke for tonight. You continue floating through the darkness. The ancient photons quietly pass through you, through galaxies, through immense cosmic voids, carrying information unchanged across billions of years. They are astonishingly old travelers. Older than every star you've ever seen, older than every planet, older than the Milky Way itself. In a way, they are the oldest photographs humanity has ever taken, except instead of capturing a smiling family gathered around a fireplace, they reveal the universe as an infant. A very hot, very energetic infant. Fortunately, one that outgrew screaming after only a few 100,000 years. Cosmic parenting, it seems, requires exceptional patience. As your journey continues, you imagine looking at a detailed map of this ancient radiation. At first glance, it appears almost perfectly uniform. Every direction glows at nearly the same temperature. That alone tells an incredible story. The early universe was remarkably smooth, not perfectly smooth, just smooth enough. Tiny differences, mere fractions of a degree, appear sprinkled across the map like faint fingerprints. Those minute irregularities would eventually become everything: galaxies, stars, planets. People lying awake listening to sleepy documentaries. Every magnificent structure in the observable universe began as unimaginably small variations hidden inside this ancient glow. You find something deeply comforting about that. Great complexity emerging from tiny imperfections. Historians still argue whether early philosophical ideas about a unified cosmos bear any meaningful resemblance to modern cosmology, or whether drawing those comparisons simply reflects humanity's tendency to reinterpret old ideas through new discoveries. Either way, the desire to understand beginnings stretches across cultures and centuries. It seems curiosity itself has remarkable longevity. You drift onward. The microwave background continues surrounding you. Although microwave sounds warm and inviting, the radiation has cooled dramatically during its immense journey. Today, it measures only about 2.7 degrees above absolute zero. Not because it lost energy carelessly, because the expanding universe stretched its wavelength over billions of years. Expansion leaves its fingerprints everywhere. Even ancient light cannot escape. Here's another sleepy smile. If photons kept travel journals, the oldest entries would probably read, "Still traveling universe, somehow even bigger now." Very dedicated little messengers. You imagine following one particular photon. It leaves the young universe while Earth does not yet exist. It crosses regions where future galaxies slowly assemble. It glides through expanding cosmic voids. Dinosaurs appear, dinosaurs vanish, continents drift, humans invent language, empires rise, libraries burn. Music is written, someone eventually builds a radio telescope. Only then does the photon finally complete its unimaginable journey. Billions of years, one uninterrupted trip, no layovers, no luggage, no complaints. a wonderfully quirky historical tidbit drifts into your thoughts. Before the cosmic microwave background was discovered, a few researchers had predicted that the early universe should leave behind a faint thermal echo. The prediction seemed almost impossible to test with the technology of the time, which makes its eventual discovery feel even more satisfying. Sometimes the universe quietly waits for humanity to build the right instrument. Patience, once again, wins. You begin noticing something quietly profound. The oldest light in existence is still arriving, every moment, every second, even now. The universe continues telling its earliest story to anyone willing to listen carefully enough. That story carries a subtle warning. Everything changes. The brilliant fireball became transparent. Transparent space produced galaxies. Galaxies gave birth to stars. Stars forged the elements that would one day become oceans, forests, and curious observers. Nothing remained exactly as it began. The same expansion that preserved this ancient light also guarantees future change. One day, unimaginably far ahead, even these precious photons will become increasingly difficult for future civilizations to detect. Their wavelengths will stretch farther and farther until the oldest surviving message from the birth of the cosmos fades into near undetectability. It is as though the universe whispers its autobiography more softly with every passing age. You realize that you are extraordinarily fortunate. You exist while the oldest light is still visible, while galaxies still decorate the heavens, while evidence of cosmic history remains scattered across the night like clues waiting to be noticed. The universe has not yet erased all of its memories, but it has already begun. And as you continue your quiet voyage, another realization slowly rises from the darkness. Even if the ancient light survives for ages yet to come, the stars themselves cannot burn forever. Their fires, too, are living on borrowed time. The long, slow fading of the cosmos has already begun. The ancient glow gradually fades behind you. Not because it disappears, but because your attention shifts towards something far more familiar. Stars, those brilliant points of light, have accompanied humanity for as long as anyone has looked upward. Sailors trusted them. Farmers planted by them. Storytellers filled them with heroes, monsters, and impossible romances. They have always seemed wonderfully permanent. The stars have done an excellent job maintaining that illusion. The universe knows otherwise. You drift toward a magnificent spiral galaxy suspended like a luminous whirlpool in the darkness. Its graceful arms curl outward, decorated with blue-white clusters where newborn stars blaze with youthful energy. From a distance, the galaxy appears timeless. Inside, it is anything but. Stars are constantly being born. Stars are constantly dying. Galaxies are less like photographs than bustling cities, where every glowing window represents another story unfolding. Yet even the busiest city eventually quiets when fewer new residents arrive. The same is becoming true for the universe. One mainstream historical fact reminds you how recently humanity truly understood this process. During the early 20th century, astronomers such as Cecilia Payne-Gaposchkin demonstrated that stars are composed primarily of hydrogen and helium, overturning earlier assumptions that they were made from materials much like Earth's crust. Her groundbreaking work transformed stellar astronomy and revealed the simple ingredients behind nature's greatest furnaces. Hydrogen, just the simplest element in existence, given enough time and gravity. Simplicity creates brilliance. You float deeper into the galaxy. Immense clouds of cold hydrogen drift through its spiral arms like quiet weather systems stretching across hundreds of light years. Inside these clouds, gravity patiently gathers gas into denser knots. Eventually, one knot becomes heavy enough, pressure rises, temperature climbs, fusion ignites, a star is born. No trumpets sound. No cosmic ribbon-cutting ceremony takes place. The universe simply lights another candle. It has repeated this process for billions of years, but not forever. Here's your first gentle joke of the evening. If stars had birth certificates, the universe would probably misplace most of them. Record keeping becomes surprisingly difficult when your filing cabinet is 100,000 light-years wide. As your journey continues, you notice something subtle. Not every region of the galaxy glows equally brightly. Some stellar nurseries bustle with activity. Others lie strangely quiet. Astronomers have discovered that the universe today produces far fewer new stars than it once did. Billions of years ago, galaxies formed stars at astonishing rates. It was something of a cosmic baby boom. Today, business has slowed considerably. The great reservoirs of cold hydrogen that fuel star formation are gradually being consumed. Every newborn star represents another small withdrawal from a finite account. The universe is spending its savings, bitterly, without panic. But unmistakably. Imagine visiting a forest where no new trees have sprouted for centuries. The old giants still stand proudly. Birds still sing among their branches. Life continues. Yet you quietly realize the future forest will not resemble the present one. Something essential has changed. That is the universe today, still magnificent, still brilliantly alive, yet noticeably quieter than in its youth. Historians still argue whether ancient cultures viewed the stars primarily as eternal divine objects or as living entities capable of change. Since myths often describe celestial beings in surprisingly dynamic ways, despite the apparent permanence of the night sky, the stars themselves, of course, never asked for mythology. They were busy fusing hydrogen. You drift past a young blue star. It shines with astonishing intensity. Blue stars burn hot, very hot. They also live surprisingly short lives. Compared with our sun, many of these brilliant giants exhaust their fuel with remarkable impatience. Cosmic brilliance often comes with abbreviated schedules. Meanwhile, smaller red stars sip their hydrogen so carefully that many will continue shining for trillions of years. They're the universe's marathon runners. The blue giants are enthusiastic sprinters. Both strategies work. One simply requires considerably fewer birthday candles. There's your second sleepy smile. The galaxy slowly rotates beneath you. Clusters of ancient yellow stars gather near its center. You realize many of them have witnessed almost the entire history of this galaxy, long before Earth existed. They were already shining, long after humanity is gone. Some may still remain. Time stretches differently among the stars. A wonderfully quirky historical tidbit drifts into your thoughts. In medieval Europe, some scholars believed new stars could never appear because the heavens were considered perfect and unchanging. Then, in 1572, observers witnessed an astonishing new star blazing into view, the supernova carefully documented by Tycho Brahe. The event challenged centuries of assumptions and reminded humanity that even the sky evolves. The heavens had quietly been changing all along. People had simply misunderstood the performance. You continue onward. Entire regions of the galaxy now reveal aging stellar populations. Many of the brightest blue stars have already lived fast and vanished. What remain are calmer, older suns glowing with gentle yellow and orange light. The galaxy itself seems to be entering middle age, not elderly, not yet, simply mature. You begin imagining the far future. Hundreds of billions of years from now, fresh star formation becomes increasingly rare. Galaxies gradually exhaust the raw material needed to create new generations. The old stars continue shining. One by one, importantly, like candles left burning after a celebration has ended. Eventually, only long-lived red dwarfs dominate the darkness, tiny, steady, unhurried. Some of these little stars may outlive today's universe by unimaginable stretches of time. Their patience borders on absurdity. If one kept a diary, today's galaxies would appear only in the opening chapter. You smile at that thought? Perhaps slowness is an underrated survival strategy. The silence surrounding you deepens again. Not because stars are disappearing overnight, because the rhythm of creation itself is changing. The universe is gradually shifting from an age of birth toward an age of endurance. That transition carries unexpected elegance. Nothing rushes. Nothing collapses all at once. The cosmos simply becomes a little less productive with every passing billion years. One fewer stellar nursery here, another quiet molecular cloud there. Like an orchestra finishing its loudest movement before easing into softer notes. You realize something unexpectedly hopeful. Scarcity does not erase beauty. A single ancient star shining faithfully through trillions of years possesses a dignity all its own. The universe seems to understand this. It does not fear aging. It simply continues patiently, gracefully. Yet another kind of object waits farther ahead, one that forms when stars finally exhaust every last reserve, objects so dense that gravity itself becomes almost overwhelming. They appear eternal, unchanging, invincible, at least, until time reveals otherwise. Even the darkest giants of the cosmos are not exempt from the slow passage of eternity. The elderly stars gradually fade behind you. Not because they have stopped shining, but because your attention is drawn towards something that shines only by refusing to let light escape. Ahead, tucked into the quiet heart of a galaxy, rests an object so strange that even the universe seems to pause respectfully around it. A black hole. The name is wonderfully misleading. It suggests an empty hole punched through space, a dark tunnel leading somewhere mysterious. In reality, it is almost the opposite. A black hole is not empty. It is an astonishing concentration of matter packed into a region so compact that gravity becomes overwhelmingly powerful. You drift closer, carefully, very carefully. Fortunately, tonight's journey is conducted entirely through imagination, because reality would offer considerably fewer return tickets. Here's your first gentle joke. Black holes have excellent customer retention. Visitors rarely leave reviews. Around the black hole, stars continue orbiting as though circling an invisible king. Great streams of hot gas spiral inward, heating until they blaze brighter than entire galaxies before finally slipping beyond the event horizon. The invisible boundary from which nothing, not even light, can return. That boundary fascinates you. Nothing special appears to mark it. No glowing wall, no cosmic warning sign reading, "Beyond this point, refunds unavailable." Crossing it would feel surprisingly ordinary. At least from the viewpoint of the traveler. The extraordinary part comes afterward. One mainstream historical fact reminds you just how remarkable humanity's understanding has become. In 2019, the Event Horizon Telescope collaboration released the first direct image of a black hole's shadow, revealing the supermassive black hole at the center of the galaxy Messier 87. After decades of theoretical work, people finally glimpsed evidence of one of nature's strangest creations. It looked almost exactly as Einstein's equations had predicted. The universe, once again, quietly rewarded patience. You continue circling the enormous object. Supermassive black holes like this one contain millions, or even billions, of times the mass of our Sun. Despite their terrifying reputation, they rarely wander through space, consuming everything nearby like hungry vacuum cleaners. Gravity simply doesn't work that way. If the Sun were magically replaced by a black hole of equal mass, Earth's orbit would remain almost exactly the same. The unfortunate difference would be the complete disappearance of sunlight. That would make gardening slightly more challenging. There's your second sleepy smile. The black hole itself would remain surprisingly calm, almost indifferent. Gravity asks no questions. It simply responds to mass. As you continue your journey, you begin noticing something unexpected. Black holes seem permanent, almost eternal. Stars are born, stars die, galaxies merge, civilizations rise and vanish. The black holes remain. For a long time, scientists believed they might last forever. After all, if nothing escapes them, how could they ever disappear? Then, in the 1970s, an astonishing idea emerged. Theoretical physicist Stephen Hawking proposed that black holes are not completely black after all. Quantum effects near the event horizon should allow them to emit an incredibly faint form of radiation. Today it bears his name, Hawking radiation. The concept feels almost mischievous. The universe quietly whispers, "Even my most permanent objects have expiration dates." The radiation is unimaginably weak. For enormous black holes like the one before you, the effect is so tiny that they absorb far more energy from their surroundings than they lose. But imagine waiting. Not millions of years, not billions, not trillions, far longer. Eventually, after timescales so enormous they make the current age of the universe seem like a single afternoon, even these gigantic objects slowly evaporate, one particle. Then another pedantly, almost imperceptibly. Historians still argue whether Hawking radiation will ultimately prove exactly correct in every detail, or whether a future theory of quantum gravity will refine our understanding of what truly happens near an event horizon. The debate remains one of the deepest in modern physics. Nature has not yet revealed the full answer. You continue floating nearby. The galaxy around the black hole gradually changes through unimaginable ages. Stars collide less often. Fresh, stellar nurseries become scarce, just as you observed earlier. The great spiral arms slowly lose some of their youthful brilliance. Meanwhile, the black hole quietly waits. It has mastered waiting. Another wonderfully quirky historical tidbit drifts into your thoughts. In the 18th century, the English natural philosopher John Michell proposed the idea of dark stars, whose gravity might become so strong that light could not escape. He worked entirely within Newtonian physics, long before Einstein developed general relativity. His idea was not a modern black hole, but it was a remarkably imaginative step toward one. Sometimes curiosity arrives centuries before the mathematics catches up. You imagine standing beside this black hole after 10 trillion years. The surrounding galaxy looks older, calmer. Many bright stars have already completed their lives. The central giant still remains. Another trillion years pass, then another. Galaxies continue evolving. Expansion steadily carries distant systems beyond view. The black hole barely seems to notice. It simply exists. If mountains represent patience on Earth, black holes represent patience written across eternity. Here's another small smile. If black holes attended family reunions, they'd probably spend several quadrillion years telling everyone, "I'm not going anywhere." Technically, they'd be almost right, because Hawking radiation never completely forgets. The universe keeps its quiet promises. Nothing remains unchanged forever. Even the most stubborn objects eventually surrender to time. That realization surprises you. The terrifying reputation of black holes begins softening. They no longer seem like immortal monsters. Instead, they resemble ancient guardians standing watch through unimaginable ages before eventually taking their own final bow. You continue drifting away from the galactic center. Behind you, the enormous black hole remains wrapped in darkness. Ahead, the future stretches farther than imagination comfortably follows. Stars will continue fading. Black holes will eventually evaporate. Galaxies themselves will become quiet collections of aging remnants. The universe seems determined to outweigh every structure it creates. And then an even stranger possibility begins quietly emerging. What if the stars are not the only things destined to disappear? What if ordinary matter itself, the atoms that build galaxies, planets, oceans, mountains, and even you, may not be eternal either? the thought arrives gently, not as fear, as curiosity, because the deepest emptiness may still lie unimaginably far ahead, waiting for even matter to loosen its grip on existence itself. The great black hole disappears behind you, not because it has vanished, but because even something so enormous eventually becomes just another distant memory against the backdrop of eternity. You continue onward. By now, time has become almost meaningless. Millions of years pass in what feels like a quiet breath. Billions drift by with the calm rhythm of waves reaching a shore. Trillions scarcely deserve mentioning anymore. Your imagination has slowly adjusted to scales that would have seemed impossible back when Earth was still visible behind you. The universe has a remarkable way of changing your definition of a long time. Ahead lies an era no human has ever witnessed, not because it is hidden, because it has not happened yet. The galaxies are older now, much older. The brilliant blue stars that once lit their spiral arms have long since disappeared. The steady yellow suns have also begun to fade into history. Tiny red dwarf stars remain the most faithful sources of light, quietly burning their hydrogen with astonishing thrift. Some still shine, many no longer do. The cosmos is growing dim, not suddenly, not dramatically, simply, patiently. You float through a galaxy that no longer resembles the vibrant whirlpool you visited earlier. Instead, it feels like walking through an ancient library after closing time. The shelves still stand, the books still exist, but very few new stories are being written. One mainstream historical fact quietly echoes through your thoughts. During the 20th century, physicists working on what became the standard model of particle physics discovered that all ordinary matter is built from a surprisingly small collection of fundamental particles. Every mountain, ocean, planet, tree, and person ultimately shares the same tiny building blocks. It is a wonderfully elegant idea, complexity emerging from simplicity. Yet elegance does not necessarily guarantee permanence. Among the many unanswered questions in modern physics is one that seems almost unbelievable. Is the proton, the particle sitting quietly inside every atom, truly eternal? Or does it possess an unimaginably long lifetime before eventually decaying? So far, every experiment has found protons to be astonishingly stable. If they do decay, they survive for at least far longer than the current age of the universe. Far, far longer, but far longer is not the same as forever. You let that distinction settle. It feels strangely important. Here's your first gentle joke of the evening. Protons appear to have an excellent attendance record. They've shown up to every cosmic event for nearly 14 billion years. Human resources would be impressed. You continue drifting. Imagine waiting not trillions of years, but numbers so enormous that even black holes have begun contemplating retirement. If proton decay truly occurs, and scientists do not yet know whether it does, ordinary matter slowly begins to unravel, not explosively, not all at once. One particle here, another there, across spans of time so immense that language itself struggles to remain useful. The stars are already gone. The planets have become frozen relics. Galaxies are little more than sparse collections of stellar remnants. Now even atoms may begin surrendering their remarkable stability. It is an astonishing thought. Everything familiar, the rocks beneath your feet, the water flowing through rivers, the calcium in your bones, depends upon particles that may simply endure, or perhaps one day quietly transform. Historians still argue whether philosophical ideas about impermanence influenced modern scientific thinking in any meaningful way, or whether the similarities are merely fascinating coincidences noticed after the fact. Either way, both philosophy and physics occasionally arrive at surprisingly similar questions. What truly lasts? The universe answers slowly. Nothing obvious. You drift past what was once a planetary system. Its central star has long since become a dim stellar remnant. The planets continue orbiting out of habit, though no sunrise has warmed them for ages beyond counting. If atoms remain stable forever, these silent worlds may persist almost indefinitely. If they do not, even stone eventually forgets how to be stone. A wonderfully quirky historical tidbit floats gently into view. Ancient Greek philosophers like Democritus imagined that matter was built from indivisible particles called atoms. They had no particle accelerators, no quantum mechanics, and no modern experiments, only careful reasoning. Ironically, today's physicists have learned that those indivisible atoms are themselves composed of smaller structures, and even those structures raise new questions about permanence. Curiosity, it seems, has always enjoyed peeling back one more layer. You smile quietly, the universe appears fond of unfinished puzzles. If proton decay never happens, matter survives into astonishingly distant futures. If it does happen, the process is unimaginably slow. Either way, there is no dramatic ending, no final countdown. The cosmos prefers whispers over fireworks. Here's another small smile before we continue. Imagine being assigned to monitor proton decay. Estimated observation time, several octillion years. Bring snacks, perhaps several galaxies worth. Although, by then, the galaxies may already have left. You continue your impossible voyage. The remaining stars have become incredibly scarce. Black dwarfs, white dwarfs, neutron stars, occasional black holes. The brilliant diversity of the earlier universe has settled into quiet simplicity. The great age of light has ended. The age of remnants has begun. Even the language feels softer, less urgent, more reflective. You realize that the universe has not become hostile. It has become economical. Every source of usable energy is gradually spent. Every brilliant process eventually slows. Nothing appears wasteful. Nothing appears rushed. Only patient transformation. That patience has accompanied your journey from the very beginning. From the first galaxies, through the great cosmic voids, past the fading microwave background, into aging stellar populations, toward ancient black holes, now into the uncertain future of matter itself. The pattern remains remarkably consistent. Time wins every conversation, yet something quietly refuses to disappear. Even in this sparse future, space itself remains. The stage survives even as many of the actors leave, and that raises a question stranger than anything you've encountered so far. What exactly is empty space? Is it truly nothing? Or have you been traveling through something far more mysterious all along? Because the vacuum, the seemingly perfect emptiness surrounding every galaxy, every star, every lonely particle, is about to reveal that it is not empty in the ordinary sense at all. The silence has one more secret waiting beneath it. You have traveled through lonely galaxies. You have crossed deserts of almost unimaginable emptiness. You have watched ancient light drift across billions of years, seen stars slowly exhaust their fuel, and followed black holes into futures so distant they scarcely fit inside language. By now, you might feel quite confident about one thing: space is empty. The universe smiles once again. Not quite. You slow your journey and simply float. Nothing appears nearby. No stars, no planets, no drifting clouds of gas, no wandering comet quietly passing through, just silence. If you reached out your hand, there would seem to be absolutely nothing waiting to greet it. Yet, according to modern physics, this apparent nothingness is among the busiest places in existence. That sounds delightfully backwards. It is, and that's precisely why physicists find it so fascinating. For centuries, many people imagined a vacuum as perfect emptiness, a place where absolutely nothing exists. It seems like such a straightforward idea. Take everything away, surely what remains is nothing. Quantum physics gently interrupts. Actually, that single word has launched countless headaches. At unimaginably tiny scales, the vacuum is not completely quiet. Instead, it possesses restless energy. Tiny fluctuations constantly ripple through what appears, from ordinary experience, to be perfect emptiness. These fluctuations are so small and so fleeting that they never resemble ordinary objects. You won't find miniature elephants popping into existence for a fraction of a second. Physics is strange. Not that strange. Here's your first sleepy joke. If the quantum vacuum ran a hotel, particles would check in and check out so quickly that housekeeping would never notice. The idea sounds almost magical. It isn't magic. It is one consequence of the wonderfully peculiar mathematics governing the quantum world. One mainstream historical fact helps place this revolution in perspective. During the early 20th century, scientists such as Max Planck, Niels Bohr, and later many others laid the foundations of quantum mechanics, revealing that nature behaves very differently at extremely small scales than everyday intuition would suggest. The universe, it turned out, was under no obligation to match common sense. Common sense evolved for throwing rocks and avoiding hungry animals. It was never optimized for understanding the vacuum between galaxies. You continue drifting through this seemingly empty region. Nothing changes visually. The darkness remains calm. Yet your imagination now overlays an invisible layer beneath that stillness. Tiny quantum fluctuations, momentary changes, subtle uncertainty woven into the fabric of reality. It is almost like watching the surface of a perfectly calm lake while knowing that countless microscopic ripples constantly dance beneath the reflections. The lake appears peaceful. Its smallest motions remain hidden. That hidden activity matters enormously. In fact, many physicists believe these quantum fluctuations in the incredibly early universe were stretched by cosmic expansion, eventually becoming the tiny density differences that grew into galaxies themselves. The magnificent cosmic web you visited earlier may owe its existence to microscopic fluctuations in what looked almost like nothing. That is an astonishing thought. The largest structures in the universe perhaps began with unimaginably tiny irregularities, greatness emerging from subtle beginnings once again. Historians still argue whether philosophical concepts of nothingness from ancient traditions bear any meaningful relationship to the quantum vacuum described by modern physics, or whether the similarities are merely poetic comparisons rather than genuine intellectual connections. Either way, the word nothing has never been quite as simple as it first appears. You continue floating. Your mind begins quietly redefining emptiness. Perhaps empty space is less like a blank sheet of paper and more like a calm ocean whose smallest waves never entirely disappear. Invisible, restless, alive with possibility. A wonderfully quirky historical tidbit drifts gently through your thoughts. The philosopher Aristotle famously argued that nature abhors a vacuum. He believed true emptiness could not exist because space would always be filled with something. Modern physics did not entirely prove him right, but it did reveal that even the emptiest vacuum possesses properties far richer than anyone in antiquity could have imagined. Sometimes history enjoys partial victories, not complete agreement, just intriguing echoes across centuries. You smile at that. The universe seems perfectly content, allowing different generations to uncover different pieces of the same puzzle. Here's another gentle laugh before we drift onward. If you ever complain that nothing is happening, the quantum vacuum would respectfully disagree. It's just operating on a schedule much too small for human calendars. You continue through the darkness. The silence feels different now. Less empty, more patient. The absence surrounding you is no longer merely an absence. It has character, potential, structure hidden beneath simplicity. Then another question quietly arrives, perhaps the most unsettling one yet. If even the vacuum contains energy, could that energy determine the ultimate fate of the universe? Astronomers today often describe something called dark energy, a mysterious phenomenon associated with the accelerating expansion you encountered earlier. No one yet knows exactly what dark energy is. It may be related to the energy of empty space, or perhaps something entirely different. The answer remains one of the greatest open questions in cosmology. The universe has not shown all its cards, not yet. You imagine standing in the middle of an immense cosmic void once more. Earlier, it seemed almost barren. Now you understand it differently. Even there, the vacuum quietly exists with its own remarkable properties. The void was never truly nothing. It was simply quieter than everything else. That realization feels unexpectedly comforting. Silence, after all, is not the absence of music. Sometimes it is the space that allows music to exist. The universe appears to understand that lesson beautifully. Stars shine because darkness surrounds them. Galaxies become magnificent because emptiness frames them. Even thought itself often grows clearest during moments of stillness. Perhaps the cosmos has been teaching the same quiet principle all along. You continue your journey. Ahead, beyond all the mysteries of particles and expanding space, another question begins slowly taking shape. One that has lingered beneath every lonely galaxy and every vast cosmic void. If the universe is so unimaginably immense, if stars have existed for billions of years, if planets seem astonishingly common, then why has the silence remained so complete? Where is everyone? The emptiness between galaxies suddenly feels less like geography, and more like a question waiting patiently for an answer. The question arrives so quietly that you almost miss it. It doesn't flash across the darkness. It doesn't echo through the void. It simply settles beside you like an old companion who has been waiting patiently for the right moment. Where is everyone? You have crossed galaxies. You have wandered through cosmic deserts so empty that a single atom felt like a crowded neighborhood. You have watched ancient light, aging stars, black holes, and the restless vacuum itself. Every step of the journey has whispered the same unsettling theme. There is an astonishing amount of room. Surely, you think, room alone should have encouraged company. After all, the universe has had plenty of time. Our own galaxy contains hundreds of billions of stars. Modern astronomy has revealed that planets appear to be remarkably common. Many stars host entire families of worlds, some rocky, some gaseous, some frozen, some perhaps wrapped in warm oceans beneath gentle skies. Statistically speaking, possibility seems almost unavoidable. Yet possibility and certainty are not the same thing. You continue drifting through the Milky Way, looking not only with your eyes but with your imagination. Somewhere below, a planet circles a quiet orange star. Elsewhere, another world glides around a red dwarf that may shine for trillions of years. Perhaps rain falls there, perhaps mountains rise. Perhaps nothing more complicated than bacteria has ever existed. Or perhaps someone is looking upward from an alien coastline at this very moment, wondering exactly what you are wondering. One mainstream historical fact brings this mystery into sharp focus. In 1950, during a casual lunchtime conversation, physicist Enrico Fermi reportedly asked a question that became famous throughout science. Where is everybody? It sounds almost playful. It is anything but. If intelligent civilizations are common and the galaxy is so old, why haven't we found convincing evidence of them? The question became known as the Fermi Paradox, although it is really less a paradox than an invitation to think carefully. You let that invitation linger. There are no easy answers, only possibilities. Some are comforting, others are not. Here's your first gentle joke before we wander into deeper waters. Perhaps every civilization spends its first 1,000 years arguing about whose telescope budget should be approved. Interstellar exploration delayed by committee. Some things may truly be universal. You drift onward. Imagine a galaxy where intelligent life emerges once every million years. That sounds incredibly rare, yet over billions of years, many civilizations could still appear. Given enough time, some might develop technologies capable of exploring nearby stars over longer spans, perhaps entire regions of the galaxy. The Milky Way is ancient, older than Earth by billions of years. Even slow expansion across the stars might eventually leave visible traces. And yet, so far, silence, not absolute silence. We detect countless natural radio signals, pulsars ticking like celestial clocks, exploding stars, galaxies humming across enormous distances, but no universally accepted evidence of another technological civilization. The quiet remains. Historians still argue whether Fermi himself intended his famous question as skepticism about extraterrestrial life, or merely as an invitation to examine assumptions more carefully. Like many memorable remarks, its meaning grew richer as others continued discussing it. You continue floating between the stars. The loneliness you noticed earlier now feels different. Before, it belonged to geography. Now it belongs to possibility. Perhaps life itself is extraordinarily rare. Maybe the chemistry leading from simple molecules to living organisms happens only under astonishingly specific circumstances. Or perhaps simple life appears frequently, while complex life almost never follows. Evolution is remarkably creative. It is also remarkably unpredictable. A wonderfully quirky historical tidbit drifts gently into view. In the 19th century, some respected astronomers sincerely believed they could observe vast canals crisscrossing the surface of Mars. The supposed canals inspired dreams of an advanced civilization desperately moving water across a drying world. Entire novels and public imaginations flourished around those imagined structures before better observations revealed that the canals had never existed at all. The human mind has always been eager to find neighbors, sometimes a little too eager. You smile softly. Hope is a powerful lens. Here's another sleepy laugh. If aliens are watching us, they may still be trying to understand why humans voluntarily attend meetings that could have been messages. Some mysteries transcend biology. The galaxy stretches around you in magnificent silence. You imagine countless worlds, some covered by endless oceans, some wrapped in frozen methane clouds, some orbiting twin suns, some wandering alone through interstellar darkness after being ejected from their parent systems. Everyone represents another experiment conducted by nature. Most may never produce life. Some perhaps do. A few, just possibly, nurture intelligence. And intelligence introduces entirely new uncertainties. Technology, culture, choices, history. A civilization might flourish for millions of years, or disappear after only a brief moment. The universe measures time generously. Civilizations may not. You find yourself thinking about timing once again. Earlier you realized humanity exists during a rare era when distant galaxies remain visible. Perhaps contact with other civilizations also depends on timing. Two intelligent species separated by 1 million years may miss one another completely, despite occupying the same galaxy. Like ships crossing the same ocean centuries apart, neither ever suspects the other. That image feels unexpectedly poignant. The silence no longer seems quite so mysterious, only more complicated. One possibility leads naturally to another. Perhaps civilizations deliberately remain quiet. Perhaps interstellar communication proves unimaginably difficult. Perhaps the galaxy is alive with intelligence expressed in ways humanity has not yet imagined. Or perhaps the emptiness is trying to tell you something. No conclusion feels entirely satisfying. That may be the most honest place to stop. The universe does not always owe immediate answers. Sometimes it simply offers beautiful questions. You drift past another quiet star. Its planets continue circling faithfully. Whether anyone stands beneath those skies tonight remains unknown. The uncertainty itself becomes part of the journey. you realize that loneliness and solitude are not quite the same thing. Loneliness is painful, solitude can be peaceful. The universe often feels more like the second than the first. It is not shouting, it is waiting potently. And somewhere ahead, among the countless ideas scientists have proposed to explain this profound silence, lies one of the most unsettling possibilities of all. What if civilizations are not absent because they never appeared, but because almost none survived long enough to fill the stars? The next step of your journey leads toward that haunting possibility, not as a certainty, only as another quiet question whispered by the empty universe. The silence stays with you. Not the uncomfortable silence of an unanswered phone call or an awkward conversation that has drifted into uncertainty. This is older than language itself. It stretches across the stars with remarkable patience, asking nothing, demanding nothing, simply existing. You continue floating between lonely suns. Some shine brightly. Others have already settled into quieter old age. Every one of them reminds you that somewhere on some distant world, life could have begun, yet the darkness remains strangely free of obvious neighbors. Earlier, you asked where everyone is. Now another question quietly replaces it. If intelligent civilizations do appear, what happens to them? Scientists have proposed many possibilities. None have been confirmed. Some are hopeful, others are unsettling. Together, they form one of the most fascinating collections of ideas in modern cosmology. Among them is a concept known as the Great Filter. The name sounds like a machine hidden somewhere deep in the universe. It isn't. It is simply a way of asking whether there exists an extraordinarily difficult step that almost no civilization successfully passes. Perhaps life itself is incredibly difficult to start. Perhaps simple organisms rarely become complex. Perhaps intelligence is unusual. Perhaps technological societies almost always disappear before reaching the stars. The Great Filter is not a theory claiming to know the answer. It is a framework reminding us that somewhere between lifeless chemistry and a galaxy-spanning civilization, there may be an obstacle so formidable that almost nobody succeeds. One mainstream historical fact quietly supports the seriousness of this discussion. In 1961, astronomer Frank Drake introduced what became known as the Drake equation, an attempt to estimate the number of communicative civilizations in our galaxy by considering factors such as star formation, planetary systems, and the likelihood of life and intelligence emerging. It was never intended to produce a precise answer. Instead, it organized humanity's questions into a form scientists could discuss systematically. Sometimes the greatest achievement of an equation is not solving a mystery. It is teaching everyone how to ask better questions. You drift onward, imagine countless planets forming across billions of years. Some never develop oceans, others lose their atmospheres. Some remain frozen forever beneath dim red suns. A few become warm, stable worlds where chemistry patiently experiments for millions upon millions of years. Eventually, perhaps, life begins. But beginning is not the same as continuing. Evolution has no guarantee of producing intelligence. Even intelligence guarantees nothing beyond itself. Here's your first gentle joke before the ideas become too heavy. Evolution has spent billions of years conducting research and development. The project management meetings must be absolutely enormous. You picture an alien shoreline. Tiny organisms thrive in shallow waters. Millions of years pass. Complex creatures emerge. Forests spread. Eyes evolve. Brains become larger. One species eventually looks upward and asks questions about the stars. Everything appears wonderfully promising. Then history begins. Technology, culture, discovery, power, choices. A civilization's greatest achievements may also become its greatest tests. Historians still argue whether technological progress naturally leads toward greater long-term stability, or whether every advanced society inevitably creates new risks that earlier civilizations never had to face. Human history offers examples supporting both perspectives. The universe has not yet revealed which one ultimately prevails. You continue drifting through the quiet galaxy. Some researchers imagine the great filter lies behind us. Perhaps the emergence of complex life required such an astonishing chain of unlikely events that intelligent civilizations are already incredibly rare. If that is true, humanity may have crossed the hardest threshold without realizing it. An unexpectedly hopeful thought. Others imagine the filter still lies ahead. That possibility feels rather heavier, not because it predicts disaster, because it reminds every technological civilization that survival may require wisdom equal to intelligence. The stars themselves remain perfectly neutral. Gravity offers no advice. Cousins provides no moral guidance. The universe simply unfolds according to its laws. A wonderfully quirky historical tidbit slips into your thoughts. During the late 19th century, several inventors genuinely believed that powerful radio transmitters might soon allow direct conversations with beings on Mars. Newspapers occasionally reported optimistic claims about imminent contact. The excitement reflected not gullibility so much as extraordinary optimism. Humanity had just discovered new ways to communicate across continents. Why not across planets? Reality proved more complicated. Hope, however, has always traveled remarkably fast. You smile. Optimism is rarely wasted, even when it arrives early. Here's another sleepy laugh. Imagine finally receiving an alien message after centuries of waiting, only to discover it's reminding everyone to update their software. Some experiences may truly unite the cosmos. You drift farther still. The galaxy grows quieter. The stars seem almost contemplative. You begin realizing something subtle. The great filter is not frightening because it claims certainty. It is unsettling because uncertainty remains. Science has not located the filter. It may not even exist as a single obstacle. Perhaps there are many smaller challenges. Perhaps each civilization follows a unique path. Perhaps the silence has countless different explanations. Each true somewhere, the universe often prefers complexity over simple answers. That pattern has followed you throughout this journey. The cosmic voids were not completely empty. Black holes were not completely black. The vacuum was not truly nothing. Why should the silence between civilizations possess only one explanation? It probably doesn't. You continue floating beneath an ocean of stars. Somewhere, perhaps, another civilization asks the same questions. Perhaps they, too, wonder whether the galaxy feels strangely quiet. Perhaps they imagine themselves alone. The thought is oddly comforting. Said uncertainty can create invisible companionship, even across impossible distances. The emptiness no longer feels entirely empty. It feels full of unanswered possibilities, and perhaps that is enough. For now, ahead, time stretches even farther than before, not toward the birth of civilizations, not toward their disappearance, toward something quieter, the gradual fading of memory itself. Because as expansion continues and stars grow ever scarcer, the universe begins doing something almost impossible to imagine. It slowly forgets. Not through intention, not through choice, simply because distance, time and entropy patiently erase the visible traces of what once was. Even history, it seems, has a finite horizon. And you're about to watch the cosmos become its own forgotten story. The stars still shine. A few of them, at least. Their gentle light drifts across a universe that has become quieter than at any point in your journey so far. The vibrant spiral galaxies of earlier ages have long since settled into calmer shapes. Bright blue stars are memories. New stellar nurseries are exceedingly rare. Even the great black holes that once seemed immortal have begun their impossibly slow farewell. You continue drifting. By now, You are no longer measuring distance. You are measuring memory. The two have become strangely connected. Back on Earth, memory feels personal. It lives inside photographs, libraries, songs, and stories passed from one generation to another. Entire civilizations devote extraordinary effort to preserving the past because humans instinctively understand how easily memories disappear. The universe preserves history differently. It stores memories in light. Every photon crossing space carries information about where it came from and when it began its journey. When astronomers observe a distant galaxy, they are not seeing it as it exists today. They are seeing ancient light finally arriving after traveling for millions or billions of years. In a very real sense, the night sky has always been a museum. You have been walking through its galleries all evening. One mainstream historical fact beautifully illustrates this idea. When astronomers first recognized that distant galaxies were so far away their light had traveled for millions of years before reaching Earth, the night sky transformed from a simple collection of objects into a collection of different moments in history. Looking farther into space became equivalent to looking farther into the past. Few discoveries have changed humanity's perspective so profoundly. You continue floating. Earlier, that ancient light seemed almost comforting. Now something changes. The accelerating expansion of the universe slowly begins removing those historical records, one by one, not by destroying them, by carrying them beyond reach. Imagine the world's greatest library resting on a slow-moving ship. Each year the ship drifts slightly farther from shore. The books remain perfectly intact. The stories survive. But eventually the distance becomes too great for anyone to read another page. That is what cosmic expansion quietly does to history. The past still exists. Access does not. Here's your first gentle joke. Future librarians would have a rather difficult checkout policy. Requested galaxy unavailable. Estimated return date never. You smile softly. Even eternity occasionally struggles with overdue books. The darkness around you deepens. Galaxies beyond your local group have vanished from view. Not because they ceased existing, because their light can no longer overcome the ever-growing expansion of space. Future observers, living trillions of years from now, may honestly conclude that their lone galaxy represents almost the entire universe. They would not be foolish. They would simply lack the evidence you still possess today. Knowledge, you realize, depends not only upon intelligence but also upon opportunity. Historians still argue whether future civilizations, isolated inside a single gravitationally bound galaxy, could reconstruct the true history of cosmic expansion using subtle physical clues, or whether that chapter of the universe's story will become permanently inaccessible. The answer remains uncertain. Time itself controls the experiment. You continue drifting through unimaginable ages. The familiar constellations of humanity vanished long ago. Even the concept of a constellation has become meaningless. Without distant galaxies decorating the heavens, the sky feels simpler, smaller, almost provincial. It is rather like standing inside an enormous palace after every room except one has quietly disappeared. The remaining room still feels impressive. Only later do you realize how much has been lost. A wonderfully quirky historical tidbit slips gently into your thoughts. Throughout much of history, people believed the stars themselves were fixed forever upon a celestial sphere. Their positions seemed eternal because human lifetimes were too short to notice significant changes. Only careful measurements accumulated across generations revealed that stars possess their own motions, quietly rearranging familiar patterns over immense spans of time. Even the constellations were temporary. The universe had been changing all along. You simply needed enough patience to notice. Here's another sleepy smile. If future astronomers publish a textbook titled "Everything in the Universe," It may consist of one galaxy and several hundred pages explaining why nothing else appears to exist. Peer reviewers might politely ask for broader sampling. Unfortunately, there wouldn't be any. You drift onward. Mirror continues fading, not personal memory, cosmic memory. The microwave background you visited earlier has stretched into wavelengths so enormous that detecting it becomes nearly impossible. The oldest surviving light grows quieter. Galaxies disappear beyond the observable horizon. Evidence of the Big Bang itself slowly slips beneath the threshold of observation. The universe begins erasing the footprints leading back toward its own beginning, not intentionally, merely through relentless expansion. That realization feels unexpectedly emotional. Imagine discovering an old family photograph, then watching the image slowly fade year after year until only blank paper remains. The family once existed. The memories remain meaningful, but the visible evidence quietly disappears. The cosmos performs something remarkably similar. It is not destroying history. It is allowing history to drift beyond reach. You find yourself appreciating the present moment more deeply. Humanity lives during an extraordinarily fortunate chapter of cosmic history. The oldest light is still visible. Distant galaxies still illuminate the darkness. The large-scale structure of the universe remains observable. Future generations, if separated from us by unimaginable stretches of time, may inherit a sky containing far fewer clues. The universe has offered you a rare opportunity, not because you are special, because you arrived at precisely the right moment. That thought feels surprisingly peaceful. The cosmos is neither generous nor cruel. It simply unfolds painfully, elegantly. According to laws that never hurry, as you continue your silent voyage, another realization begins quietly taking shape. Even after history fades, even after galaxies disappear beyond sight, even after stars themselves have gone dark, the universe does not end. It simply changes into something slower, colder, more uniform. Ahead lies the longest evening imaginable, a future where usable energy grows scarce, change becomes almost imperceptible, and the cosmos settles toward its final twilight. The last great chapter has almost arrived. The universe does not collapse into silence. It settles into it. That distinction matters. Throughout your journey, you've discovered that the cosmos rarely chooses dramatic endings. Galaxies did not suddenly vanish. Stars did not extinguish themselves in a single breathtaking moment. Even black holes began their unimaginably slow farewell, one particle at a time. Everything has unfolded with extraordinary patience. Now, patience itself becomes the dominant feature of reality. You continue drifting through a future so distant that even the word future feels inadequate. The remaining stars are almost gone. The galaxies that once glittered across the heavens have either merged into quiet collections of stellar remnants or slipped forever beyond the observable horizon. The great cosmic web, once stretched across billions of light years like luminous lace, has become impossible to see. Not because it was destroyed, because distance quietly carried its pieces beyond one another's view. You float through darkness that is no longer dramatic. It is gentle, almost contemplative. A few isolated remnants still glow faintly. Ancient white dwarfs slowly surrender their leftover heat. Rare neutron stars drift through the silence. Here and there, the last evaporating black holes complete journeys that began billions upon billions of years earlier. The universe feels less like a bustling city and more like a quiet house after every guest has gone home. Nothing tragic has happened. The evening has simply ended. One mainstream historical fact provides the scientific framework for this vision. During the 19th century, physicists developed the concept of entropy, especially through the work of Rudolf Clausius and others studying thermodynamics. Entropy is often described as a measure of how energy becomes increasingly spread out and less available to perform useful work. Over immense spans of time, this simple principle suggests a universe that gradually becomes more uniform. The phrase many people know is heat death. It sounds alarming. In reality, it is surprisingly quiet. No explosion announces its arrival. No great cosmic alarm clock rings. The universe simply approaches a state where almost every meaningful difference has faded away. Think about a hot cup of tea left on a table. At first, heat flows rapidly into the surrounding air. Eventually, the tea reaches room temperature. After that, almost nothing changes. Not because time has stopped, because everything has become nearly equal. Heat death is that simple idea expanded to the scale of the cosmos. You smile softly. Somewhere, a forgotten kettle has become the universe's favorite metaphor. There's your first sleepy joke. You continue floating. Energy still exists. That is important. The universe has not run out of energy. Instead, energy has become so evenly distributed that almost none remains available to create new structures, new stars, or new complexity. Imagine an enormous waterfall. Its power comes from water standing higher in one place than another. Flatten the entire landscape until every drop sits at exactly the same level. The water still exists. The waterfall does not. Difference creates possibility. Uniformity creates stillness. Historians still argue whether the heat death scenario will ultimately describe the universe's true fate, or whether unknown aspects of dark energy, quantum gravity, or future discoveries could significantly alter that picture. Science remains careful. Predictions extending trillions upon trillions of years into the future naturally contain uncertainty. The universe has surprised astronomers before. It may yet do so again. You continue through the immense quiet. There is something unexpectedly beautiful about it. No frantic collisions. No violent bursts of creation. Only immense calm. The silence you first encountered between galaxies has now expanded until it embraces nearly everything. It is no longer the exception, it is the rule. A wonderfully quirky historical tidbit drifts gently through your thoughts. In the 19th century, the Scottish physicist William Thomson, later known as Lord Kelvin, speculated about the eventual heat death of the universe long before modern cosmology had established that the universe itself was expanding. His vision lacked many pieces we understand today, yet it demonstrated how simple physical laws could inspire remarkably bold predictions about unimaginably distant futures. Curiosity has always enjoyed thinking far ahead, sometimes astonishingly far. Here's another quiet smile. If someone scheduled a meeting near the heat death of the universe, punctuality would become wonderfully easy. Nothing much would happen while anyone was running late. You drift onward. The darkness no longer feels empty in the unsettling sense. Instead, it feels complete. Every stage of your journey seems to echo here. You remember the crowded spiral galaxies, the immense cosmic voids, the ancient microwave background, the last generations of stars, the patient black holes, the mysterious quantum vacuum, the unanswered questions about distant civilizations. Each memory now resembles a gentle ripple spreading across an otherwise calm lake. The ripples eventually fade. The lake remains. You realize something quietly profound. The universe has never been racing toward an ending. It has simply been evolving through different kinds of beauty. Youth offered blazing stars and crowded galaxies. Middle age offered structure, complexity, and curious observers. Old age offers tranquility. Not every story requires a dramatic finale. Some conclude with a long exhale. You allow yourself to drift without destination. There is no urgency anymore. No race to the next discovery. Even curiosity slows into peaceful observation. The remaining particles continue their unimaginably quiet existence. The vacuum still possesses its subtle quantum restlessness. Time itself continues flowing. Nothing has truly stopped. The pace has merely become so gentle that change feels almost like stillness. You understand now why the emptiness of the universe seemed so unsettling at the beginning of your journey. You mistook silence for absence. Instead, silence was simply another form of presence. It framed every star, every galaxy, every possibility. Without it, nothing else could have stood out. Ahead lies only one final reflection, not about how the universe ends, but about why its overwhelming emptiness may have been necessary from the very beginning, because somewhere within all this astonishing silence, there was room for one small blue planet, one curious species, and one quiet listener drifting peacefully beneath the stars tonight. You slow almost to a stop, not because there is anywhere to anchor yourself, and not because the universe has finally run out of places to explore. There are still distances beyond comprehension in every direction. There are still questions waiting patiently in the darkness. There are still mysteries that no telescope, no equation, and no curious civilization has completely unraveled. But your journey has reached a different kind of destination. Understanding rarely arrives like a lightning bolt. It settles quietly, the way snow covers a landscape overnight. You look back, not with your eyes, but with memory. You remember the first lonely stars you encountered, scattered across a darkness that seemed almost impossible to accept. You remember discovering that galaxies are not crowded neighborhoods, but isolated islands. You remember crossing the immense cosmic voids, where even a single wandering atom felt like an unexpected companion. You remember watching the universe stretch itself, patiently increasing the distance between everything that once seemed comfortably close. You remember following the oldest light still traveling through space, ancient photons carrying whispers from a universe too young to contain a single star. You remember the long decline of stellar birth, the patient endurance of black holes, the possibility that even matter itself may one day surrender to time, and the strange realization that empty space is not truly empty at all. Every step has led here, not toward an answer, toward a perspective. One mainstream historical fact quietly reflects humanity's own remarkable journey. In 1990, the Voyager 1 spacecraft turned its camera back toward home at the suggestion of astronomer Carl Sagan, capturing the famous pale blue dot photograph. Earth appeared as little more than a tiny speck suspended in a sunbeam, almost disappearing against the vast darkness of space. That image changed countless lives. Not because it revealed something new about Earth, because it revealed something new about us. From so far away, every mountain, every ocean, every empire, every celebration, every disagreement, every dream, and every bedtime story occupied a point of light, smaller than a single pixel. The universe had quietly reminded humanity of its scale, not to diminish us, to place us honestly within something far greater. You drift onward. The silence feels familiar now. When this journey began, the emptiness seemed unsettling. Now it feels almost welcoming. You realize that silence has been present during every beautiful moment you've witnessed tonight. Without darkness, stars would never glitter. Without distance, galaxies would lose their graceful shapes. Without vast stretches of nearly empty space, gravity could never have sculpted the magnificent cosmic web that holds the visible universe together. Emptiness was never the enemy, it was the stage. Here's one final gentle joke. The universe spent nearly 14 billion years perfecting minimalist interior design. Even professional decorators would probably admit that's impressive. You smile softly. The joke drifts away as peacefully as everything else. Historians still argue whether future generations will look back on the 21st century as the moment humanity truly began understanding its place in the cosmos, or merely as the first chapter in a much longer story of discovery. Perhaps both are true. Every generation mistakes the horizon for the destination until someone keeps walking. A wonderfully quirky historical tidbit comes to mind. In parts of medieval Europe, people sometimes believed the Milky Way was a heavenly road, traveled by souls on their final journey. Long before astronomy revealed billions of distant stars, human imagination had already transformed that pale ribbon of light into a pathway connecting Earth with eternity. Science replaced the legend. Wonder remained. Perhaps wonder has always been the constant, not certainty, not answers. Wonder, you think about every unanswered question still floating somewhere in the darkness. What exactly is dark energy? Will proton decay ever be observed? What truly happens inside a black hole? Does intelligent life quietly flourish beyond our sight? Or are we one of only a handful of curious voices ever to ask these questions? No certainty arrives, and somehow that feels perfectly peaceful, because the universe has never promised complete understanding, only endless opportunities to keep exploring. You continue drifting beneath the remaining stars. Some shine with the steady confidence of old age, others have already faded into memory. The ancient microwave background still whispers across space. The quantum vacuum continues its invisible dance. Expansion patiently carries distant galaxies beyond one another's horizons. Everything keeps moving. Nothing hurries. The universe has no deadlines, only time. And time, as you have discovered tonight, possesses almost infinite patience. The journey now becomes quieter still. The stars soften until they resemble tiny candles glowing behind a thin morning mist. The great galaxies become gentle memories, no heavier than dreams waiting for sunrise. The immense cosmic voids no longer seem frightening. They feel spacious, peaceful, comfortably still. You allow every thought to become lighter than before. There is nothing left to solve tonight. No equation demanding an answer. No mystery insisting upon resolution. The universe will still be here tomorrow, quietly expanding, quietly changing, quietly holding its countless secrets beneath the same ancient sky. For now, simply rest. Imagine yourself floating effortlessly through the calm darkness, surrounded not by emptiness, but by possibility. The silence asks nothing of you. The stars expect nothing from you. They simply shine, as they always have, patient companions across unimaginable ages. May your breathing become as gentle as drifting starlight. May your thoughts slow like galaxies moving through eternity. May every worry grow smaller beneath this endless sky. And when sleep finally arrives, may it carry you as peacefully as the universe has carried every photon, every star, every world, and every quiet dream through the endless ocean of time.